The Ford Mustang was dying. Sales had plummeted to just 73,716 units in 2009, the lowest since the Fox body era. Ford executives were secretly discussing killing the nameplate altogether, and the 4.6-liter modular V8 was getting embarrassed by Hyundai Genesis coupes at traffic lights. But how did one engine completely reverse the Mustang's fate? Why did Ford spend $500 million developing an all-new V8 when bankruptcy loomed? And what made this motor so special that it saved an American icon? These are 20 mind-blowing facts about how the 5.0 Coyote saved the Ford Mustang. Number 20. The identity crisis that nearly killed everything. Ford's Mustang had lost its way by 2008. The retro-styled S197 initially boosted sales, but buyers quickly realized the 4.6-liter modular V8 was a dog. 300 horsepower sounds decent until you realize the Camaro SS was pushing 426. The Challenger RT made 375. Hell, the Genesis Coupe with its Turbo 4 was keeping pace with Mustang GTs. Ford dealers reported potential buyers literally laughing when they heard the performance specs. One dealer in Texas said customers would test drive the GT, then immediately walk over to the Chevy dealer next door. The situation got so bad that Ford's North American president admitted in a closed-door meeting that they were considering turning the Mustang into a front-wheel drive economy coupe. Imagine that, a Mustang based on the Focus platform. Internal documents later revealed that this plan made it all the way to final approval stages. The only thing that stopped it was a last-minute presentation by a group of engineers who had been secretly working on something radical. They called it Project Coyote, and they promised it would change everything. Ford's board gave them 18 months and $500 million. If they failed, the Mustang as we knew it would die. Number 19. Ford's moonshot luxury benchmark. Here's something nobody talks about. The Coyote wasn't designed to beat the Camaro. Ford benchmarked BMW's V8s, specifically the S65 from the M3. Engineers bought 3 M3s and tore them apart, studying every component. They were obsessed with achieving BMW levels of refinement while maintaining American muscle car character. The NVH, noise, vibration, harshness, targets were insane for a muscle car. They wanted the Coyote to be as smooth as a luxury sedan, at idle but sound like thunder when you floored it. Ford spent $2 million just on exhaust sound tuning. They built a special acoustic laboratory where engineers would listen to exhaust notes for 8 hours a day, fine-tuning the harmonics. One engineer later admitted he couldn't listen to music for 6 months after the project because his ears were so sensitized to engine frequencies. The team even hired musicians to help analyze the sound frequencies. They wanted specific notes to dominate at different RPMs, a low B-flat at idle, transition into D at 3,000 RPM, hitting a perfect fifth harmony at redline. This obsession with refinement would pay off in ways nobody expected. Number 18. The Clean Sheet 5.0 Mandate. When Ford greenlit the Coyote project, they made a radical decision. No parts from the modular engine family would carry over. Nothing. This was financial insanity. The modular platform had cost billions to develop, and Ford was essentially throwing it away for the Mustang. But engineers had discovered something damning. The modular's architecture was fundamentally limited. Its tall deck height, narrow bore spacing, and 2-valve head design couldn't compete with modern engines. Computer simulations showed that even with unlimited development budget, the 4.6 could never exceed 350 naturally aspirated horsepower while meeting emission standards. The Coyote team started with a blank computer screen. Every dimension, every angle, every material choice was optimized using supercomputers that ran simulations 24 hours a day. Ford even poached engineers from Ferrari's F1 program to help with valve train design. The clean sheet approach meant the Coyote would share more DNA with racing engines than with any previous Mustang V8. Number 17. All-aluminum deep skirt block strength. The Coyote's block looked like it was designed for a Le Mans prototype, not a street car. Deep skirt construction meant the block extended below the crankshaft centerline, creating an incredibly rigid structure. Ford engineers tested the bare block to 1,500 horsepower before it showed any measurable distortion. But here's the crazy part. They designed it to be manufactured using the same equipment as their truck engines. This manufacturing genius meant the Coyote could be built for only slightly more than the old 4.6, despite being infinitely more advanced. The block featured cross-bolted main caps like exotic supercars, but Ford developed a new casting process that made them affordable. They also integrated piston oil squirters normally found only in high-end sports cars. These squirters spray oil directly onto the piston undersides, reducing temperatures by up to 50 degrees. This one feature alone allowed Ford to bump compression to 11.1 while still running on regular fuel. Number 16. 6-bolt mains and forged crank focus. Ford engineers had nightmares about the LS engine's reputation for strength. Chevy guys would brag about pushing 1,000 horsepower through stock bottom ends. The Coyote team's response was to over-engineer everything. 6-bolt main caps, 2 vertical bolts, and 4 horizontal bolts per cap created a bottom end stronger than many racing engines. The forged steel crankshaft was gun-drilled for weight reduction, but tested to withstand 8,500 RPM continuously. Ford's durability testing was borderline sadistic. They ran engines at maximum power for 300 hours straight. Then they'd tear them down and measure every component. If anything showed more than 0.01 inches of wear, they redesigned it. One engine survived 1,000 dyno pulls to redline without any measurable degradation. The connecting rods were forged powder metal with fracture-split caps, a technique borrowed from Formula One that created perfect alignment every time. These rods were tested to 9,000 RPM for 100 hours. Not because street engines would ever see those speeds, but because Ford wanted bragging rights. Number 15. High-flow heads and quad cam. Breathing. The Coyote's cylinder heads flowed like nothing Ford had built before. Each port was shaped using computational fluid dynamics software that calculated millions of airflow possibilities. The result was ports that flowed 315 CFM on the intake side, better than many aftermarket racing heads. But the real magic was the 4-cam design. Independent cam timing for intake and exhaust meant the engine could optimize breathing for any RPM or load condition. At idle, the cams would retard for smooth running. At wide open throttle, they'd advance for maximum power. Ford's engineers discovered they could even use cam timing to reduce pumping losses, improving fuel economy by 8%. The valve train used roller finger followers with hydraulic lash adjusters. No more valve adjustments ever. The springs were beehive-shaped to reduce mass and allow higher RPM. Every valve was made from hollow stainless steel filled with sodium for cooling. These exotic materials and designs were typically reserved for 6-figure supercars, but Ford's manufacturing scale made them affordable in a Mustang. Number 14. TI-VCT Variable Cam Timing Strategy. Twin independent variable camshaft timing sounds boring until you understand what Ford achieved. The Coyote could change its personality completely based on driving conditions. Light throttle cruise? The engine would essentially run an Atkinson cycle, prioritizing fuel economy. Hammer the throttle? It transformed into a race engine with aggressive cam timing. Ford's calibration engineers spent 10,000 hours optimizing the cam timing maps. They discovered they could use exhaust cam retard to create an internal EGR effect, reducing emissions without external hardware. Intake cam advance at part throttle improved fuel economy by 12% compared to fixed cam timing. But the party trick was torque management. By constantly adjusting all 4 cams, the Coyote delivered a table-flat torque curve from 2,000 to 6,000 RPM. Magazine testers couldn't believe the dyno sheets. The torque barely varied across the entire RPM range. This made the engine feel larger than its 5.0 liters, pulling like a big block from any RPM. Number 13. The Ford 12 HP launch that shocked rivals. When Ford announced the 2011 Mustang GT would make 412 horsepower, Chevrolet engineers thought it was a typo. The Camaro SS with its larger 6.2-liter V8 made 426, but barely. How did Ford extract so much power from a smaller engine? The answer was RPM. The Coyote redlined at 7,000 RPM, a full 1,000 RPM higher than the Camaro's LS3. High RPM meant more power strokes per minute, translating to more horsepower. But high RPM also meant incredible stress. Ford's solution was obsessive attention to rotating mass. Every component was analyzed for weight reduction. The pistons used a special aluminum alloy developed for aerospace applications. The wrist pins were DLC coated and gun-drilled hollow. Even the piston rings were exotic, thin, low-tension designs that reduced friction by 30%. The result was an engine that revved like a sport bike but lasted like a truck motor. Initial dyno testing showed 418 horsepower, but Ford deliberately underrated it to avoid insurance issues. Many stock Coyotes dyno at 380, 390 wheel horsepower, suggesting the real crank number was closer to 440. Number 12. GT versus Camaro SS Showdown Reality. The magazine comparisons were brutal for Chevrolet. Despite having more displacement and 14 more horsepower on paper, the Camaro SS consistently lost to the Mustang GT. Motor Trend's testing showed the Mustang hitting 60-mile-an-hour kh in 4.3 seconds versus the Camaro's 4.6. The quarter mile told the same story, 12.7 at 111 mph for the Ford, 13.0 at 110 for the Chevy. But straight-line performance was only part of the story. The Coyote's broad power band made the Mustang easier to drive fast. You didn't need perfect shifts to stay in the power. The engine pulled hard from 2,000 RPM to redline. Track testing revealed another advantage. The Coyote's superior heat management meant consistent lap times. The LS3 would heat soak and lose power after a few hard laps. Ford engineers had included oil coolers, transmission coolers, and differential coolers as standard equipment. The Camaro required expensive track packages to match the Mustang's cooling capacity. One professional driver summed it up perfectly. The Camaro might have more peak power, but the Mustang has more usable power everywhere. Number 11. Boss 302 Roadrunner. Halo effect. Ford knew they needed a halo car to showcase the Coyote's potential. The Boss 302 was that car, but its development was pure insanity. Engineers started with a standard Coyote and threw Ford's budget out the window. CNC-ported heads flowed like NASCAR engines. Forged pistons and H-beam rods replaced the already stout stock parts. A revised intake manifold added runners from the GT500, creating a Frankenstein hybrid that breathed like nothing else. The result was 444 horsepower and an 8,250 RPM redline. But power was only part of the story. Ford's special vehicle team spent 6 months at racetracks developing the suspension. They tested 47 different spring and damper combinations. The final setup could pull 1.04G on street tires. The Boss 302 embarrassed cars costing twice as much. It lapped Laguna Seca faster than the BMW M3, Audi RS5, and Mercedes C63 AMG. Car and Driver called it the best handling Mustang ever built. The halo effect worked perfectly. Suddenly, everyone wanted a Coyote-powered Mustang, even if they bought the base GT. Number 10. Track Key and Laguna Magic. Here's where Ford got sneaky. Every Boss 302 came with 2 keys, a black daily key and a red track key. The red key transformed the car into something barely street legal. Ford's engineers had hidden an entirely different calibration in the ECU. Insert the track key, and the engine gained 40 horsepower from more aggressive timing and fuel maps. The The red line jumped to 8,400 RPM. Launch control activated. The stability management allowed lurid slides. Even the gauge cluster changed, displaying lap timers and G-meters. But the Laguna Seca edition was the real monster. Named after the famous California track, it deleted the rear seat, added a full cage, and included front splitters that looked like snowplows. Ford claimed it was street legal, but many states disagreed. California wouldn't even register them without modifications. Only 750 were built, and they're now worth more than new Shelby GT500s. The Tracky technology proved Ford could offer supercar features in a Mustang. It also showed the Coyote's tunability. Same hardware, different software, massive performance gains. Number 9. Aftermarket tunability ignites fandom. The Coyote became the LS engine for Ford guys. Endlessly modifiable and surprisingly tough. Within months of release, aftermarket companies discovered the engine's incredible potential. A simple tune and exhaust could add 50 horsepower. Cams and heads pushed naturally aspirated builds past 550 horsepower. Forced induction was where things got crazy. The stock bottom end handled 700 wheel horsepower reliably. Built motors eclipsed 1,500. Hellion's twin-turbo kit made down 200 wheel horsepower on pump gas. The engine's architecture seemed designed for boost, with thick cylinder walls and robust cooling passages. Ford accidentally created the perfect platform for modification. The deep skirt block meant incredible rigidity under boost. The 6-bolt mains laughed at 1,000 lb-ft of torque. Even the stock head gaskets held 20 pounds of boost. Tuners discovered the factory left massive headroom in every component. The fuel injectors could support 600 horsepower. The oil pump flowed enough for 8,000 RPM operation. The cooling system handled twice the stock heat load. It was like Ford's engineers knew exactly what owners would do and designed accordingly. Number 8. Real-world MPG without sacrifice. The Coyote achieved something supposedly impossible. Muscle car performance with economy car fuel consumption. EPA ratings showed 26 highway MPG, but real-world results were even better. Magazine testers regularly saw 28 to 30 MPG on highway cruises. Some hypermiling owners reported 32 MPG. How? The TIVCT system essentially turned the Coyote into two different engines. During cruise, late intake valve closing reduced pumping losses. The engine operated on an Atkinson-like cycle, prioritizing efficiency over power. Direct mechanical injection meant precise fuel control. The 11.1 compression extracted maximum energy from every drop. But the real secret was the 6-speed transmission's tall overdrive gears. At 70 mph, the engine loafed along at 1,600 RPM. Combined with aerodynamic improvements, the Mustang could cruise at highway speeds while barely sipping fuel. Owners reported driving from Los Angeles to Las Vegas on a single tank. The forums lit up with photos of trip computers showing 400-mile ranges. Suddenly, you could daily drive a 400-horsepower muscle car without bankruptcy. The Coyote proved performance and efficiency weren't mutually exclusive. Number 7. F-150. Adoption proves versatility. Ford's masterstroke was put in the Coyote and the F-150. Truck buyers initially scoffed. Why choose a 5.0 when the EcoBoost V6 made more torque? Then they drove both. The Coyote's linear power delivery and V8 soundtrack won converts. No turbo lag, no complex systems, just smooth, predictable power. The engine proved incredibly versatile. It could tow 11,300 pounds without breaking a sweat. Contractors loved the reliability. No turbos to fail, no complex cooling systems to maintain. Fleet managers discovered Coyote-powered trucks lasted longer with lower maintenance costs. The truck version got unique upgrades. Forged steel connecting rods replaced powder metal for durability. Compression dropped to 10.51 for regular fuel compatibility. Oil coolers grew larger for towing duty. but the character remained unchanged, a high-revving, sweet-sounding V8 that happened to work perfectly in a truck. Sales exploded. By 2015, the 5.0 became the second most popular F-150 engine. Ford built over 400,000 Coyote-powered trucks annually. The economy of scale drove costs down, making the engine even more profitable in Mustangs. The truck connection also meant constant development. Every improvement for truck durability benefited Mustang reliability. Number 6. Global emissions and reliability wins. The Coyote passed every global emissions test thrown at it. Euro 6, China 6, Carb ULEV, all conquered without compromise. Ford engineers achieved this through obsessive attention to combustion efficiency. The chamber design promoted complete burn-in with minimal hot spots. Port and direct injection worked together to eliminate particulates. Cold start emissions, traditionally V8 Achilles heel, were slashed by 90%. The catalyst heated in under 20 seconds thanks to careful exhaust manifold design. Variable cam timing reduced pumping losses, cutting CO2 emissions. But reliability was the real achievement. Ford subjected Coyotes to torture tests that would kill lesser engines. Arizona summer testing, 120-degree ambient temperatures, full throttle for hours. Alaska winter testing, cold starts at -40, immediate full throttle acceleration. Death Valley towing, maximum loads up 18% grades in extreme heat. One test engine ran 500,000 miles with only oil changes. Teardown revealed minimal wear. Ford engineers said it could run another $500,000. Taxi companies in Middle East countries reported million-mile Coyotes still running strong. The engine's overbuilt nature meant normal use barely stressed components. This reliability transformed Mustang's reputation from fragile toy to dependable daily driver. Number 5. Gen 2 Refinements and CMCV Edition. The 2015 Coyote update seemed minor, but delivered major improvements. Charge motion control valves sounded like emissions nonsense but transformed low-end response. These valves closed at low RPM, creating turbulence that improved combustion. Torque below 3,000 RPM jumped 15%. The dead zone that plagued Gen 1 engines vanished. Cylinder heads got larger valves and reshaped ports. Flow increased to 325 CFM despite stricter emissions requirements. Compression bumped to 11.2.1 through piston redesign. The intake manifold grew shorter runners for high RPM breathing. Power climbed to 435 horsepower, but drivability improvements mattered more. The engine felt larger, pulling from idle with big block authority. Magazine testing showed improved fuel economy despite more power. The Gen 2 proved Ford's platform strategy worked. Same basic architecture, continuous refinement, better results. Aftermarket support exploded as tuners discovered Gen 2's increased potential. Naturally aspirated builds pushed past 500 wheel horsepower. Forced induction applications saw 20% gains from better head flow. The CMCV system, initially mocked by enthusiasts, became appreciated for its street performance benefits. Number 4. Gen 3 Dual Injection Power Bump. The 2018 Coyote went nuclear with both port and direct injection. This wasn't just about power, it was about combustion perfection. Port injection handled low-load situations, providing excellent atomization. Direct injection kicked in under load, cooling the combustion chamber and allowing more timing. Combined, they eliminated knock while supporting higher compression. Power soared to 460 horsepower with 420 lb-ft of torque, but the real story was the power band. Peak torque arrived at 4,600 RPM and stayed flat to redline. The engine pulled harder above 6,000 RPM than most pushrod V8s at their peak. High-pressure direct injection meant 2,900 psi fuel delivery. This enabled lean burn cruise modes that pushed highway mileage past 30 mpg. Cold starts improved dramatically as direct injection heated chambers instantly. Emissions dropped another 20% despite the power increase. The Gen 3 also got a new intake manifold with dual throttle bodies. This design equalized airflow to all cylinders, improving power and reducing vibration. Even the oil pump was redesigned, with variable displacement reducing parasitic losses. Every component was optimized using lessons learned from 7 years of production. Number 3. Coyote swap culture explosion. The Coyote became the Gen Z small block Chevy. Kids were stuffing them into everything: Fox bodies, SN95s, even classic Mustangs. The swap made sense. Complete takeout engines cost $3,000. The computer and wiring were straightforward. Power output embarrassed built Windsor engines costing twice as much. Control pack systems made standalone operations simple. Ford Performance sold everything needed for swaps: mounts, headers, wiring, cooling, all available from the dealer. The community support was incredible, with forums documenting every possible combination. Coyotes went into Ford Rangers, making 400 horsepower mini trucks. Crown Victoria builds created 4-door sleepers. One maniac stuffed a Coyote into a Miata, creating a 2,200-pound missile. The engine's compact size helped. Despite 4 cams, external dimensions matched traditional small blocks. The deep sump oil pan fit most chassis without modification. Accessory drives tucked tight to the block. Even the height cleared most hoods. But the sound sold swaps. The Coyote's shriek at 7,000 RPM was intoxicating. No pushrod V8 sounded as exotic. YouTube videos of Coyote swaps went viral, inspiring more builds. The culture fed itself. More swaps meant more parts, lower prices, easier builds. Number 2. Sales momentum and brand reboot. The numbers told the story. Mustang sales jumped from 73,716 in 2009 to 137,893 in 2011. By 2015, Ford sold 223,898 Mustangs globally. The Coyote didn't just save the Mustang, it transformed it into a global phenomenon. Dealers couldn't keep GTs in stock. Used values skyrocketed as buyers realized the Coyote's potential. Insurance companies raised rates after too many owners discovered the engine's capabilities. But beyond sales, the Coyote rebuilt Mustang's credibility. Automotive journalists who had mocked the 4.6 now praised Ford's engineering. European magazines compared Mustangs favorably to BMW M cars. The engine won International Engine of the Year awards. Ford's marketing capitalized perfectly. 5.0 badges returned after decades of absence. The sound became signature. Every commercial featured the Coyote's wail. They sponsored drag races, road courses, and drift events. The message was clear: Mustang was back. The halo effect lifted Ford's entire brand. Showroom traffic increased 40%. Buyers who came for Mustangs often left in F-150s. The Coyote proved Ford could still engineer world-class engines. Wall Street noticed, driving Ford stock from $1.50 to $18 in 5 years. And before our final revelation, don't forget to hit that subscribe button for more automotive deep dives and comment below if you knew any of these Coyote facts. Number 1. Why Coyote kept Mustang relevant forever. Here's the truth nobody at Ford will admit publicly. The Coyote was never about beating the competition in 2011. It was about creating a platform that could evolve for decades. Internal documents revealed Ford's 100-year engine strategy. They knew electrification was coming. They knew emissions would tighten. They knew the V8's days were numbered. But they also knew enthusiasts would cling to internal combustion until the bitter end. The Coyote was designed to be the last great American V8. Every component was overbuilt for future development. The block could handle 1,000 horsepower for when hypercars needed Mustang engines. The heads flowed enough for 600 naturally aspirated horsepower. The rotating assembly could spin to 10,000 RPM with minor modifications. Ford created an engine that could adapt to any future requirement. Need more power? The architecture supported it. Tighter emissions? The combustion chamber was ready. Hybrid assist? The block had mounting points. Alternative fuels? The injection system could handle anything. This forward thinking paid off immediately. When competitors scrambled to meet new regulations, Ford simply updated software. When Dodge needed a new Hemi, Ford refined existing hardware. While GM developed new architectures, Ford extracted more from the Coyote. The engine became Ford's Swiss Army knife. It powered everything from entry-level Mustangs to 800-horsepower Super Snakes. It worked in trucks, SUVs, and race cars. One basic design satisfied every need, but the real genius was psychological. Ford knew the Coyote would become legendary. They designed it to be modified, raced, and loved. Every teenager dreaming of their first Mustang wanted a 5.0. Every weekend racer knew the platform's potential. The Coyote didn't just save the Mustang in 2011. It guaranteed its survival through the electric transition. When Ford finally builds its last V8 Mustang, it will be Coyote-powered. And decades later, enthusiasts will still be building, modifying, and celebrating the engine that saved an icon. The Coyote transformed the Mustang from a dying nameplate into an eternal legend. Ford spent $500 million and created something priceless, a future for the American muscle car.